Hello? We're going to look at putting the things together that we've looked at. The domain, the range, relative maxima, relative minima, even, odd, all this list of things that are listed here in the typewritten part. But let's think just a minute about even and odd functions one more time. If I graph down here y equals x squared right down here, do you notice that if I fold it along the y-axis, the two sides would meet? That's because when we have an even function, it's symmetric with respect to the y-axis. Y equals x cubed, on the other hand, is an odd function. Notice if we fold it along the y-axis and then fold it again so that we folded it into quarters along the y-axis and the x-axis, that it would match there. So that's what happens. An odd function is symmetric with respect to the origin here. If I have a point right here, then it's reflected down here. A point here is reflected down here. So with that in mind, we're going to look at this function right here. Its domain. Remember, domain is what the x's do. How far left and how far right does it go? Well, it keeps going on and on and on and on to the left and on and on and on to the right. So it's all real numbers, or from minus infinity to infinity for the domain. The range is what the y's do. That's up and down. So it goes on and on up and on down also. So the range is minus infinity to infinity because we can use any number for y and it'll have a place on this graph. The x-intercepts are where the graph crosses the x-axis. And it crosses at 1 to the left, 1 to the right, and 3 to the right. So that's where x equals -1, x equals 1, and x equals 3. The y-intercepts, where do we cross the y-axis? Right here, 1 below, so y equals -1. Now let's look at increasing. The graph starts up right here until it gets to that point. Now remember, we want to talk about the x's here. Erase that and start again. Our ordered pair right here is 0, -1, and we're thinking about the x's. And the x where it stops increasing is 2. So remember, the y's tell us we're increasing because we're going up or down, but the x's tell us where we start and where we stop. So we write that it's increasing from 0 for x to 2. And remember, the turning points are never included. All right, for decreasing intervals, we're decreasing right here, and we're decreasing over here. So we're decreasing, let's see, how far to the left do we go? On and on to -infinity. And then we stop decreasing when we reach this point, whose x is 0. We start decreasing again with this point, where the x is 2, and keep on and on and on going to the right, so we're headed toward infinity. And we can put a union symbol or a comma there. Notice we're looking for values of x now, for which f of x, or y, is greater than or equal to 0. And let's think where that would be. Let's see, y's are positive all up in here, aren't they? And y's are positive here, and they're equal when we're on the axis. So let's describe this interval. X is going on and on to the left, so that's -infinity, until it gets to -1. Now, we're not changing from increasing to decreasing or anything here. That -1 is included because we have an equals right here. And then we have another interval. It starts at 0. Nope, that's 1, isn't it? 1, 0. Starts at 1 for x. So let's erase and put 1 for x. And it goes to 2 turns, comes down here to 3, 0. 3 for x. All up in here, y is positive, and right here and here, it's equal to 0. So we include the 1, we include the 3, and everything in between. So we get brackets right here. Okay, you with me? F of x or y is greater than or equal to 0 when all the y's are positive, right here in the heavy red, or in the heavy red dots, it's actually equal. Now let's do relative maximum. The numbers where F has a relative maximum. That would be the x's right here. So that's where x equals, and our top dog point has a 2 for its x. The relative maxima is the y, and the y of our top dog point is 3. Then I want to look for f of negative 3. Remember that our symbol here is f of x originally, and then I plugged in negative 3 in place of x. So on my graph, I'm going to look for the graph where it's negative 3 for x. Here it is, and it goes right up here. And actually that was a 4 that I graphed and I wrote over it. So we can see that the y is a 4 and the x is a negative 3. Well, if they've given me x, then I give them y. So think of what I'm given and then give them the other, and we'll have the answer. Now we want the values for which f of x equals 0 or y equals. Well, that was included here because we had to talk about the equals here. And we said y was 0 at negative 1, 1, and 3. So when x is negative 1, x is 1, and x is 3, then our y equals 0. Now let's decide if it's even, odd, or neither by looking at the symmetry. If I take my graph and fold it along the y-axis, it doesn't match, so it's not even. If I take it and fold it in quarters by folding it on the y-axis and the x-axis, it's not odd, is it? It doesn't match. So this one is neither. Okay, so we can see then how we put together all these different things in one graph.